involved. Okay, so I'm not going to look into detail of this because we have learned in detail in thermodynamics. All right, so I just leave it there. Okay, so as a summary, what we have learned in reciprocating a compressor, we are not going to look at the rotary machine, okay? So we have several cases that we must understand. Okay, we must manage to differentiate from one case to another case. So if I can write here, our first case is the VC is equal to 0. Then the second case, we have the VC, this is VC equal to 0. Second case, if VC is not equal to 0, then we have P equal to P1, and then we have T is equal to T1. The next case is VC is not equal to 0. Then we have right here, the P is not equal to P1, and the T is not equal to T1. From here, we can see that we have volumetric efficiency. This is also, we have volumetric efficiency. The volumetric efficiency of the first case is equal to 1. For the second case, it's going down. For the third case, it's further up, further going down as far as the volumetric efficiency is concerned. Okay? And then to avoid this dropping of volumetric efficiency, when we increase the pressure of delivery, then to avoid that, we go for the multi-stage compression. Okay, multi-stage compression. Right? And in multi-stage compression, we look what is being called as the intercooling. We have the case of complete intercooling and incomplete intercooling. What's the meaning of this? Okay, what's the meaning of complete and what's the meaning of incomplete? If complete, we know that the temperature of the intake of the air is equal for every stage. If incomplete, they are not the same. Okay, and then after that, we look for the pressure ratio. For each stage, same pressure ratio. What is the meaning of same pressure ratio? Meaning that for every stages, the pressure ratio is the same. Okay, it's the same. And then we have the same pressure ratio, and also we have same pressure ratio plus we have complete intercooling. When this is applied, then we know that this will be giving us what is being called as the minimum power input. Okay, and lastly is the energy balance. Right, so you must know each characteristic of what type of cases that we look for. Okay, if I put this as number, this is number 1, first case. This is second case. This is the third case. Okay, this is the fourth case. And for the fourth case, we have 4.1, we have 4.2, and we have 4.3. So this is all the cases involved. And lastly is the case number 5 is to look at the energy balance of the multi-stage, or maybe this one I can assume that this is as 4.4. Okay, so these are all the cases, right? Each case giving us a different meaning and different approach, okay, of solution. And as far as the parameter is concerned, in every equation that we are going to use, it all depend on cases. Okay, all depend on cases. Right? So that is the as far as the cases is concerned. And then as far as the parameters or the performance of the compressor, we have learned about the indicated work, which will lead us to the indicated power. Right? And then we have looked in terms of volumetric efficiency, the definition of volumetric efficiency. We have two definition or two equation, basic equation. After that, we have looked in terms what is called as the P-iso, P-isothermal. And then after P-isothermal, we look what is being called as the isothermal efficiency. Okay. And then one more parameter which is very important, that is the FAD, free air delivery. Okay, free air. This is the common type of parameters of performance that we look in terms of the compressor. So the FAD is called also known as the V naught or V dot. Okay, V dot, which is measured at P and T. The free air delivery. This is the free air condition. Okay, the P and T is the free air condition. Okay, free air condition. Okay, guys, that is what we have learned. Is there anything that I left out? Can you remember, or you can remind me? Is there any parameter that we looked that we haven't touched in? Ada tak? Maybe if as additional, maybe we can look also in terms of what we call as the mechanical efficiency. The losses during the transmission of work from a prime mover, which is maybe we can use a electric motor or engine to drive the compressor. So it's involving the mechanical efficiency. Maybe also we can consider of the motor efficiency, and because of electrical motor and etc. Okay. So also we know that often that being asked is the VS. Okay, the VS is multi-stage involving high pressure and etc. And in order to get the VS, you must know the schematic diagram of a cycle. We must know what is VA minus VD, right? And we must know the VA minus VD at what condition that we could have, right? We could have the VA minus VD at P, T. We could have the VA minus VD at P1, T1, and etc. Okay, for multi-stage, we also have VA minus VD being called as prime. Okay, which is measured at what? Measured at P, I, T, I. Right? This is for these two stages. And we also look at for multi-stage, maybe this is measured at the PX, TX, depend on how many stages that we have. Okay? So this is all you need to know. You need to understand each term, what is the meaning of each term, and also you must understand the PV diagram, because everything is being derived from the PV diagram. As far as the IP is concerned, as far as the VA minus VD, VS is concerned, okay, you must know the PV diagram. Either for first or for a single stage, and also for the multi-stage compressor. Okay, you must know all that. This is the low pressure side, this is the high pressure side. And then you must know all the normal term use A, B, C, D, the processes involved, constant pressure, polytropic compression, and etc. Okay, guys, as far as the reciprocating air compressor is concerned, that is all the what we have learned right now. Okay, what we have learned right now. Any
Doctor,
question? Yeah.
do you mind
Yeah.
scrolling up a bit until the VS part, like below FAD?
Pardon, Tiwaga, again?
Do you mind scrolling up a bit until the FAD part? Yeah, okay, perfect. Thank you, Doctor.
Okay. So this condition also, we seldom refer this as pre-air delivery, delivery. Okay, any other question? Any other thing that you want me to show you before we proceed? Ada Okay. Is that the case? What we are, siapa tu? Anybody? Tak ada? Okay. Kalau tak ada, saya nak tunjukkan several. Ya, Afiq, apa dia? Ya, Amirul, anything? Afiq, Amirul? I saw your name is being highlighted at the indicator saying that you are speaking something. Tak ada Okay. If no, let us look at the question from the textbook. I'm going to look at 12.3. Let us do together.
Hello, test.
Okay. Apa dia? Tak ada. Ya, Amirul, apa dia, Amirul?
Testing.
Oh, testing. Okay. Okay, Amirul, testing 1, 2, 3. 1, 2, 3. Can hear me, Amirul? I can hear you. You said testing. Tak apa Okay.
I have a question.
Ya, siapa tu?
Free air condition, is it the same with ambient condition? My condition is a bit
Is equal to ambient condition. Okay. Free air condition is exactly the same as the ambient condition. Okay. Any other question?
No, sir.
All right, thank you. So let us look at this question 12.3. A single stage, single acting air compressor running at 1000 ref per minute delivers air at 25 bar. For this purpose, the induction and free air condition can be taken as, you see, said that the induction and free air, okay, the induction is P1 T1 and the free air is P and T. Okay, so if you have this type of explanation or information given in the question for the induction and free air, meaning that the induction is always P1 T1 and the free air condition is P and T. It's given 1.013 bar and 15 degrees C. The FAD is 0.25 meter cube per minute. The clearance volume is 3% of the swept volume. And the stroke over bore ratio is 1.2. Okay? So if we can try to sketch this particular problem in terms of the PV diagram, right? This is the PV diagram. And also we can sketch the piston cylinder. This is the intake, this is the deliver. So this is intake, this is delivery. So this is our piston. This should be our crankshaft. Okay, crankshaft is rotating. Right. Single stage. So we have sketched. This is for a single stage. Okay. And then the RPM is running at 1000. So meaning that our crankshaft is running at 1000 RPM. So we try to convert everything and put at the appropriate location. So this is our RPM 1000. Delivers air at 25 bar. So the 25 bar is our delivered pressure. Sorry. Air condition, P and T. This is the induction condition, P1, P1. And being set right here, the same value. Okay, the same, the free air induction is same value. So this is the case whereby we have P equal to P1 and T is equal to T1. This is the free air condition, this is the induction condition. And this is equal to 1.013 bar. And for the temperature is 288 Kelvin. Okay. And the FAD, so the FAD I should put right here, measured at the P1 and T1. This is the FAD. And the FAD is also being called as the V dot. And the value is, if FAD, the unit is always meter cube per minute. Okay, as far as FAD is concerned, free air delivery always shown as the unit as meter cube per minute. 25 meter cube per minute. Please remember, this is the case whereby P equal to P1, T equal to T1. If we have different, okay, if we have different value whereby the P is not equal to P1 and T is not equal to T1, the FAD is always measured at P and T. Remember that. Okay, the FAD always measured at P1, T1. It's always measured at P and T. In this case, it's equal because the question tells us the information that the induction and the free air condition is the same. Okay, again, FAD always measured at P and T. Right?
Doctor, for
then
the FAD value, sorry, Doctor, Tiwagar here.
Yeah.
For the FAD value, it's always given, or is there a way to calculate it?
It all depends. Sometimes you are being asked to calculate or to get the FAD. Okay? There are questions that you have to get the FAD based on the VA minus VD. For this particular example or question, it's given. But some other question is not given, but you must get what is the FAD. Okay, Tivaga? If I can look right here, is there any question that need to get what is the FAD? Let me see. There you see. You're being asked the free air delivery. Okay, being asked. But usually when you being asked the FAD, then the dimension or the geometry of the piston is given. Okay, it's given. You see, right here, 12.8, you're being asked to get what is the free air delivery. The FAD, this is the FAD, or the V dot. Okay, so please remember tak semestinya diberi sentiasa. Selalunya kalau diberi, kalau ikut pengalaman saya lah kalau FAD diberi, dia akan suruh cari dimension of the cylinder and the cylinder, the bore and the diameter. Okay, selalunya dia akan diberikan begitulah. Okay, so dia vice versa. So you need to understand and you need to also look the pattern of question regarding to the air compressor. Kalau beri yang ini, apa dia suruh, kalau beri yang ini, apa dia suruh cari. Okay, and then the clearance volume, this is the case whereby you have your BC is not equal to 0. Okay, so this is 0.03 of BS. Right, so maknanya sekarang ni kita boleh completekan kita punya diagram. Because kita ada VC, so this is the case where we have the VC value. So this is our top dead center. So let's say this is our bottom dead center. And given the bore and stroke, okay, bore and stroke. So what is the stroke? This is stroke, L. What is bore? This is bore, the D. Okay. So given right here, the stroke and bore, there is L over D is given as 1.2 over 1. Okay. So after completing all the data given, then you know that this is the case of VC is not equal to 0, then our AV diagram will look like this. A, B, C, and D. Remember to put the arrow on the process. Right? If you look right here, there's no volumetric index. So of course, as usual, this should be for the expansion and the compression and the expansion process is according to the polytropic process. And the first question is to ask for the bore and stroke. Okay, the bore and the stroke. If you see the question, first one is to get the bore and stroke.
Yeah, Doctor.
Yeah.
They given the polytropic index to the question below.
Oh, ada towards the end Okay, thank you. Towards the end ni ada polytropic index 1.3. Okay, we put that. Thank you. So given the n, the polytropic index is 1.3. The first question is to get the bore and stroke. So how to get the bore and stroke? What is the guide that we can get the bore and stroke? The bore and stroke is only can be get from the where the Vs is equal to pi d to see what we need to solve, right? So this is pi d squared over 4 multiplied by 1.2 d, and this will be 1.2 pi d cube over 4. Okay, 1.2 pi d cube over 4. So from here, we will get the d. But remember, we must solve for the Vs. How to get the Vs? We get the Vs always from VA minus VD. Why we get from VA minus VD? The relationship. Okay, if you look right here, this is our Vs. This is our VA. This is our VC. Okay, we can relate the Vs in terms of VA minus VC. Okay, VA minus VC. And we try to relate the VA minus VC according to the VA and also the VD. So before that, I need to put the pressure involved in this PV diagram. So this is our pressure, which is a P equal to P1. This is our pressure, which is our P, P2. Right? So we try to get the VA minus VD first. Okay, what is VA minus VD? VA minus VD. What is VA? VA is equal to VS plus VC. VS plus VC. And what is VD? We use the relationship between C and D. I've shown before this, how we get the VD. Is basically to look at the process of C to D using the polytropic relationship between point 2 and point C and point D. So this we will get is the VC P2 over P1 power of 1 over n. Okay? Then this is equal to Vs plus 0.03 Vs. And for our Vc right here, minus 0.03 Vs multiplied by the P2, in this case is 25, and our P1 is 1.013, power of 1 and 1.3. Okay, so that is our equation. So can someone calculate for me how much you get this VA minus VD? Ya, ada anybody dapat?
Uh, 0.6
0 point?
0.67.
Are you sure?
0.67.
Are you sure?
Yes, sir.
Very small?
Yeah. Just sir.
Yes, sir.
Clear again, sir.
Yeah?
Yes, sir.
Sama?
Yeah.
0.6, eh? Give me, give me,
0.677.
yeah.
0.67.
Give me four decimal point. 6,
0.67.
0.
7,
7,
8,
tak dengar.
6, 7.
6, 7 again. Yeah, yeah. Betul?
Yes, sir.
Yes, sir.
Okay, 0.6767 VS, eh? Look again, betul yang kita buat ni? Ini adalah VA. VA is VC, VS plus VC, okay. And then the VD is 0.03 VS to 25 divided by 1.013 power of 1 over 1.3. So you get this, Because you know why? Because if you write this, I can predict, I can know that the volumetric efficiency. The volumetric efficiency of this is 67.67%. From this VA minus VD. So it's quite small. So maknanya this compressor is not good. Tak apa. We let us see the value first. So this should be our first equation lah, This is our first equation. And then we need to know what is the VA minus VD. Okay, VA minus VD itself, which is equal to V dot A minus V dot D divided by D RPM. Okay. So for this VA minus VD, we look at this condition, the VA minus VD. So this condition is a P1 and T1 or the P and T. Okay. So this should be equal to M dot R T1 divided by P1. As far as the VA minus VD is concerned, at that VA minus VD, the pressure and temperature is T1, P1. Okay? It's P1 and T1. Now, it's given the T1 equal to T, the P1 is equal to P, the R value. Now we have to solve for the M. The M dot, we are going to use the free air. The 1 is equal to P T. If we are going to use the V dot right here, this V dot is the free air. So meaning that if you want to use the V dot, this is P, this is T. Don't put P1, T1, but the value is the same. Okay, the value is the same. Remember that, right? So what is P? P is 101.3 kPa. Multiply by the V dot. And in this case, the V dot for the free air delivery, V dot is given as 0.25. 0.25. Okay, divided by R, 0.287 constant, and the T is 288. So if I leave the value or the unit of V dot as meter cube per minute, meaning that we are going to have right here is kilogram per minute. I just put it here, okay? I just leave it as kilogram per minute. Okay, can someone calculate for me?
Uh, 3.06 to the
3.06. Give me four decimal point.
yes, sir. 3.06 4
For
10 to the power of -3, sir.
oh, Okay.
Yes, sir.
Everybody agree? The value of m dot? Can anyone verify the value? I don't want to proceed if the value is different. Okay tak?
I
I got the same dot.
Okay, thank you. So proceed with the V dot A minus V dot D once we have the M dot. So our M dot is a 3.064 exponential minus 3 multiplied by the R 0.287. T1 is equal to T 288 and P1 is equal to P, which is 101.3. So we are going to get V dot A minus V dot D.
Doctor, the value for P is 1.013, right?
Yeah, 0.0,
No, P tadi.
Dia tak tukar bar,
1.013.
sir.
macam mana?
dah
The
tukar
value of,
KPA tu, dah tukar KPA.
I put this in KPA. This already in KPA because given is in bar, so we need to put in KPA. So this is bar. So one bar is equal to 100. 100
Yeah, M dot,
KPA.
sir, M dot too.
The M dot.
So I think M dot is 3064.
Yeah.
Tadi saya tanya. Ada minus tak? Oh, saya
No, just
salah sini. Okay.
0.3064.
There's no exponential 10 minus 3.
No.
Just
No,
now,
sir.
I thought someone said about the exponential.
I think because it's calculated using bar.
No. I have already converted. Okay, so this one don't have, 0.34. Okay, so how much is that? Okay, anyone? V dot A minus V dot D?
0.25.
0.25?
25.
Oh ya. Yeah. Sama
Yes.
Yes,
Ya,
got
betul
the
lah,
same.
sama. It's the
Yes.
same. So you see, nampak tak? When you have the P1 equal to P and T1 is equal to T, then what you have is the same value of the V. So this is in terms of meter cube per minute. Okay? So now it's verified that when we have P1, okay, it's verified that right now we have done it. When we have this is the case, right? This is the case, then we could conclude that the V dot is equal to VA minus VD. Okay, if this is the case. We have proven that here. Okay, we will get the same thing again. So meaning that what we have right here, the VA minus VD, whereby the V dot is equal to V dot A minus V dot D. So this gives us the VA minus VD is equal to 0.25 divided by N, 1000. So what is the VA minus VD? Remember, this is in kilogram. This is in meter cube over minute. Multiply by this is 1 over minute for the RPM. So we'll get in the unit of minute. But this minute is minute is cancelled off. So we get this as a meter cube per cycle. Okay, so how much is that?
2.5 10 to the power of -4, sir.
2.5
10 to the power of -4.
-4. Okay, so this should be our equation number 2. Then we proceed with 1 equal to 2. Right? So what we have right here, what is Vs? 0.6767 Vs is equal to 2.5 power of 10 minus 4. And this will lead us the Vs is equal to okay, berapa?
So 3.694. Yes, sir. -4.
-4.
10 to the power of -4.
Okay. 3.69 power of 10 -4. So from the equation of Vs, just now we have put where is the Vs? 1.2 pi d cube over 4. 1.2 pi d cube over 4 is equal to 3.69 -4. So from here, we get the D. Okay, so what is the D?
Sir, saya dapat 0.07316, sir.
This one, 0.07316
Yeah,
meter, right?
meter, sir.
Okay, so you try to change to centimeter. If the question asks for centimeter, you put in centimeter. If the question asks for millimeter, you convert to millimeter. And for L is 1.2D. So let us check the answer. Lebih kurang kita dapat 73. 73 ke 2.3, 2.373. See, we have the answer as this one. Okay, it's correct. Now we get the volumetric efficiency, number 2. Yeah, volumetric efficiency. So that is for number 1. Now we try to get what is the volumetric efficiency, part 2. Part 2 is the volumetric efficiency. The volumetric efficiency is equal to V divided by Vs. Remember, this V is measured at P and T. Okay, measured at P and T. And in this case, this is equal to VA minus VD divided by Vs. And in this case, we have defined what is VA minus VD. This is our VA minus VD, 0.767 divided by Vs. This is Vs multiplied by 100. Then we get the volumetric efficiency as 67.67%. Let's check the answer. Yeah, 67.7%. Okay. Next question is part 3 is to get the indicated power. Number 3 is to get the IP. What is the IP? The IP is equal to, for this case, VC is not equal to 0. Then the equation is N minus 1 M dot R T 1. Sorry. Put inside. MR T2 minus T1. Okay. The T2 is equal to T1 P2 over P1 power of N minus 1 over N. And this should be 288, 25. Is it 25? The P2? 25 ya? Sorry. Betul? P2. Ya, 25 bar. (25) divided by 1.013, 0.3 divided by 1.3. So how much is that?
.53, sir.
03.53. 03?
603.53, sir.
Okay. 603.5 Kelvin. So what is our IP? 1.3 divided by 0.3. What is our M dot? Let me see what is the M dot just now. The M dot we are getting is 3064. Okay, 3064. How come it's too
M
big?
dot. M dot.
M dot 0.3.
0.3064. 0.3064.
0.3? M dot salah? Tadi saya
Ah.
tanya sini. Ni salah ke ni?
Ya, sir. 0.306.
Kalau salah, beritahu saya, jangan beritahu lambat.
M dot salah, sir.
Berapa? Berapa?
0.3064.
0.0364.
0.3, sir.
0.364. Kilogram per minit, betul?
0.30.
Dekat tengah-tengah tu ada 0, sir. 3064.
Betul lah, tadi sini ada 10 minus of 4 kan? Okay. Betul Okay, jadi sini 0.3064. So, you dapat 2 So, you get 2 kilowatt. Okay? Listen guys, kalau ada salah beritahu awal-awal Jangan tunggu Saya tak calculate, you all yang calculate The value semua saya dapat pada you all. Okay, next. Dia tanya kita the isothermal efficiency. For isothermal efficiency. Which is equal to P iso divided by IP. What is P iso? M dot RT. T here is T1 bukan T T1. Kalau formula dia adalah T1. Tapi dalam kes ni T1 is equal to T lah. Tapi formula dia adalah T1. Ln P2 over P1. 0.3064 divided by 60. 0.287. T1 kita adalah 288. Ln 25 divided by 1.013. Okay. So how much is the P iso?
So 1.353, sir.
1.353. 1.353
Yes.
So is kilowatt. So this one will be 1.353 divided by 2.0 multiplied by 100. So that is your P iso. Okay? How much is that? So kalau ikut sini, you will get around 67.7 or so.
67.65, sir. Yeah.
Okay, 7%. Okay guys, that is how you do it. For this question, Okay, so I will put that in our group. 2423. It's our 2423. Padana. Sure. Twelve point three. Where is our 12? Last one. 12.3 solution. Okay, so next we are looking at the continuing equation solution problem of this. The next one is 12.4. Okay, what is the condition of 12.4? Can we try to observe? So 12.4. The compressor of problem 12.3 has actual induction condition of 1 bar and 40 degrees C, and to deliver pressure 25 bar. Taking the bore and stroke as calculated in problem 12.3, calculate the FAD referred to 1.13 bar. And okay, let us try to make this as a different question, ya, ataupun kita cuba jangan ambil data yang ada kat atas tu lah, maybe a bit kita ambil lah, right? So kita cuba lukiskan kita punya diagram dulu, okay? Lukiskan diagram. Try to sketch the diagram and give all the terminologies or the symbol. Try to do that first. You sketch your pistons in the device. Okay, so kalau kita sketchkan dia dan kita berikan all the terms yang ada, so I'm going to sketch this, the piston cylinder, okay, going in, coming out. So this is the piston at PDC, this is our TDC, this is our BDC. Okay, so we have right here, this is P, this is T, this is P1, this is T1, this is P2, okay, and T2. So right now, what is given right here, the 1 bar is P1. And our P is equal to 10, or I put in bar, 1013 bar. Our T1, our T is equal to 288 Kelvin. And our T1 is given right here is 40 degrees C. So 40 plus 273 should be equal to 313. So this is 313 Kelvin. So we have taken this, we have taken this. And then the P2 is equal to, again, the same thing, 25 bar. We have noted this. The bore and stroke as calculated in problem 12.3, meaning that we have the same VS. Okay, the same VS as problem 12.3. So if we can look back, what is our VS? Sorry, VS. Remember what is our VS? Anybody can give me the VS? Wow. I lost it. So the VS, we are getting the VS as, which way is it? The VS is 3, ini betul please apa ni, verify. Ini betul
Yang tu betul sir.
Okay, 3.69. 3.69 power minus 4. 3.69 power 3.69. So this is 3.69. Please verify it. 3.6 3.69 10 power of 4 minus 4 meter cube. Betul saya tulis betul
Betul sir.
Okay, thank you.
Betul sir.
Alright, thank you. Lagi apa lagi diberikan? Alright, the FAD referred to this. Calculate, okay, taking the bore and stroke as calculated in problem 12.3. Calculate the FAD. You need to get the FAD. So what is FAD? FAD, which is equal to V dot. Okay, which is equal to V dot. And this V dot must be calculated at ambient condition. And this is equal to M dot RT divided by P. Okay. Right. So how about our M dot? Does our M dot differs with 12.3? What do you think?
Ambient condition sama kan sir?
Sama.
Okay.
Remember tak yang kita dapatkan FAD? VA minus VD. FAD is equal to VA minus VD. Remember the equation? Ini kalau kita ada ini, kita boleh dapat lah Tapi ingat because of the difference between P and P1, T and T1, M dot kita dah berubah tau. M dot kita bukan lagi yang pada soalan 12.3. Okay? So your FAD right now, it should be equal to this formula. Okay? So this should be your V dot. Mana saya dapat ni? Ini ialah kita dapat daripada persamaan volumetric efficiency Kalau you ingat kita punya persamaan volumetric efficiency is V divided by Vs. And then this is equal to VA minus VD kalikan dengan apa saya tulis ni? Okay, sis. Okay. Ini divided by Vs. You see from here? You get your V. This is your V. Okay? So kalau you nak tahukan di sini adalah V dot, maknanya you kena multiplykan dengan RPM. Okay, multiplykan dengan RPM. What is VA minus VD? Betul tak? 6767 kan? From previous. VA tolak VD. Guys, please check. Betul ni?
Yes.
Yes.
T kita adalah 288 dibagikan dengan T1. T1 kita adalah 313.
Sir, yang VAVD tu untuk yang ada VS ke yang tak ada VS?
Macam mana?
Yang untuk 0.6767 ni ada VS belakang dia.
Okay.
Dia ada yang lagi satu yang 2.4.
Oh. Sorry. Ya. VA tolak VD kalikan dengan tu 2.4. Tak, sekarang ni saya ambil untuk per cycle saya kalikan dengan N. Jadi VA tolak VD.
Kalau per cycle.
Oh, ada ada VS.
2.5.
Ya.
2.5.
Sini ada VS.
Yang ni ada VS lah.
Ada VS. Ya. So kita kena kalikan dengan VS. That's why dia kata gunakan VS yang sama. Dia gunakan LD yang sama, maknanya VS yang sama lah. Okay, so sini saya tambah VS. Kalikan dengan VS. VS tadi 3.6. 3.69 kali 10 negatif 4. Okay, kalikan dengan T kita adalah 288. P1 adalah 313. Kalikan dengan P1 kita adalah 1 tadi. Kenapa saya buat not ni? Sorry. Kalau buku lama ada not, sorry. Kita punya P1 kita adalah 1 bar. 1 divided by 1.013. Kalikan dengan N kita adalah 1000. So, kalau kita tengok unit unit sini adalah meter cube. Sini adalah 3.6 ni adalah VS adalah meter cube. Dan sini tak ada. Sini tak ada unit, sini tak ada unit. Kita cancel off. Kalikan dengan N 1 kalikan dengan N 1/minute. So kita akan dapati unitnya adalah meter cube per minute. Okay. Berapa tu? Kita akan dapat 0.226. Okay, berapa? Verify that.
Betul, Doktor.
Betul, sir.
Betul, sir.
0.226 meter cube per minute. Okay, so nampak agak tiba nampak macam mana ada soalan yang minta FAD, ada soalan yang minta LOD, dia ada cara dia lah ya. Okay.
Nampak, Doktor. Thank you.
Right. And then we need to calculate, kita dah dapatkan dia punya FAD, we need to calculate the indicated power. Indicated power, number 2, indicated power, IP. So IP is the same equation, sama dengan N over N minus 1 M dot R T2 minus T1. Okay. So do you think that the M dot is sama tak dengan 12.3? Problem 12.3 sama tak dengan M dot sini? You think it's the same? You look here tengok sini nampak. This is our free kan. Tadi dah 2.25, tadi dah 0.25 kan. Sekarang ni dah berubah lah. Disebabkan oleh ambient condition dengan induction condition tu berbeza. P is not kata P1, T is not T1. So kita akan dapati M dot akan berubah. So we need to calculate the new M dot based on this V dot. Yeah, based on this V dot. Okay. So kita calculate balik M dot is equal to PV dot over RT, which is equal to, kita punya P now ialah 101.3. The new one is this is a 0.226 divided by R. R kita adalah 0.287 kalikan dengan 288. Ya, ingat this one is V. So this is P, this is T. Jangan guna yang P1 T1 ya. Sebab kita ambil nilai V ni adalah pada P and T. So maknanya M dot juga gunakan pada P and T tally dengan V dot. So jangan lupa kita kena taruhkan per second. So this one divided by 60. Ya, sebab V dot di sini adalah meter cube per minute. So get the M dot.
Dapat 4.61, 4.62 sir. 10 to the power of -3.
Unit?
M3 over second. kg of second, sorry.
kg of second. 61 ke 62 62. Alright. So now we calculate what is our IP equal to 0.3 1.3. 1.3 divided by 0.3 kalikan M dot 4.63 kalikan dengan 10 negatif 3 kalikan dengan R 0.287. Okay, kalikan dengan T2 adalah, T2 tak dapat lagi kita tak calculate T2 lagi sorry. We need to calculate the T2. T2 sama tak dengan yang tadi? T2 agak sama tak dengan 12.3? T2
Itu sama sir sebab
sebab
T1
sama ke lain? Lain
sama.
kan? Sama pula kan lain. T1 kita kan lain.
T1 kita lain.
Betul tak?
Betul.
T1 kita lain. Jadi dia punya T2 pun lain. That's why we need to know betul-betul the T1 ni maksudnya apa Maksudnya T1 ni is towards the induction punya temperature So kita akan calculate the new T2. The T2 is equal to T1. Pressure ratio sama. Okay, 1 over N. T1 kita adalah sekarang ni adalah 313, bukan 288 lagi tau. Tadi sebab sama. Tapi sekarang ni the beginning of the compression process is begin at 1. So dia 3. So ni ada 25 bagikan dengan 1.013. 1 divided by 1.3. So you get higher T2. Higher T2 compared to problem 3.12.3. Okay, anybody?
Sir, dapat 3686.1.
3686.1. 3686, betul?
Ya. Ya, sir. Betul.
Beribu?
Yes, sir.
Betul
Just
ni?
Doktor, formula tu formula
Oh, sorry. Okay. Awak ikut aja tiba. Tak apa, sorry. Ni bukan formula, bukan ni. Kat sini adalah N-1, Di sini ialah, tu sebab kena check kerja saya ni. This is silly mistake lah yang biasa kita akan buat. This is N-1/N. So this is 0.3 divided by 1.3. Nasib baik saya dah biasa, tahulah kenapa besar sangat dia punya beribu punya suhu, tu tak logik lah. Okay, sorry for that. Get the new value.
Saya dapat 655.92.
655. More reasonable. Point?
92.
Okay. So our IP will be equal to 1.3 divided by 0.3 multiplied by m dot. M dot is tadi kita dapat 462 4.62 kali 10 negatif 3 kalikan dengan 0.287. T2 kita ialah 655.9 tolak dengan T1 kita ialah 313. Okay, how much? Kita akan expect dapat berapa Expect dapat
Betul sir, dapat 1.98.
1.98. Okay.
Yeah,
1.98 kilowatt. Okay. So next question, apa dia nak Kita dah calculate di indicated power, calculate also the volumetric efficiency. Okay, volumetric efficiency. So the volumetric efficiency is equal to V over Vs. Right. Kita dah ada tak? Inilah kita ni FAD lah Oh, FAD. Kita nak guna mana? Nak guna V, kita nak guna ini ke ataupun nak gunakan satu lagi? Ada satu lagi It's equal to VA minus VD over VS to T. T4.
Kata yang dekat T2 tadi tu P1 kita pakai 1 ke 1.013?
Mana?
T2.
Oh, salah Salah ni. Thank you very much. Ni salah nampak tu. Kita guna di sini ialah 1. Kaki duduk sebelah, apa dapat? Salah ni nampak ada salah ni. Kita guna 1, bukan 1.013. Guna 1. What is our new value?
657.887.
87.
657.8788.
Nah. Yeah.
Ah,
Okay. So, potong 657.9. Biar nampak salah tu ya. Jadi kita aware lah kenapa salah. Okay, new value
1.982 kilowatt.
Okay. And then volumetric efficiency, kalau kita gunakan yang ini, kita guna yang ini dulu. Ini sama dengan V So berapa V kita dapat tadi? Mana V kita? Ni V kita correct? 0.226. 0.226. Right? Kalau kita gunakan 0.226 meter cube per minit, maknanya kita gunakan sini V dot lah Betul tak? And then kita dividekan dengan kita punya VS. VS kita berapa VS kita tadi kita dah calculate
3.69
Okay, please.
dekat atas tadi doktor.
Okay, you read for me.
3.69
3.69
Yeah.
3.69
times 10 to the power of minus 4.
Okay so kita cuba tengok kita punya unit analysis. This is meter cube per minute for 0.226. Yang bawah ni adalah meter cube, betul? Untuk VS. Okay. So this 2.66 is meter cube per minute. We have to eliminate the minute. So how to eliminate the minute? Kita kena taruh minit kat atas lah. So letak kat atas maknanya apa unit yang kita ada? Kita ada unit untuk N. So we should put the N value right here. Okay, which is equal to 1000. Baru kita cancel. And multiply by 100, dapat dalam percentage. Okay. So kena bagi 0.226 bagi dengan 3.69 kali 10 kuadranti 4 kali dengan 1000. N value. Okay, N value untuk convertkan dia per cycle. Untuk V dot ni convertkan per cycle. Ataupun you berkalikan ini dengan N pun boleh, tak ada masalah. Either one lah Either one. Okay, dalam kes kita ni saya gunakan yang ini saya gunakan sebagai V. Kalau nak guna dot pun boleh maknanya guna dot. Kalau atas dot, bawah pun dot lah. So it's up to you. Okay, berapa? Jadi ini based on the first one. This is second equation. Berapa?
About 61.25, sir.
61.25.
25.
Kalau you dapat more than 67, betul tak agak? Ingat yang kita belajar, yang kita buat untuk 12.3 kita dapat 67.67% kan, betul? Jadi maknanya kalau kita dapat lagi besar daripada 67, something wrong lah kita buat kalkulasi salah. We should get less than 67%. So kita dapat less lah. So kita gunakan, now kita gunakan equation nombor 2. Okay, nombor 2. The volumetric efficiency is equal to VA minus VD. So what is our VA minus VD? 0.6767, betul tak? Bagi ni lah VS, dibagikan dengan VS, kalikan dengan TOW. TOW kita adalah 288, T kita adalah 313, P kita adalah 1, ya, kita punya PO adalah 1.013 times 100. So ni boleh cancel. Ini kita punya berapa dapat? We should get the same value lah, 61.25.
Yep, dapat lebih kurang doktor, 61.47.
Okay, so this is the answer for the part untuk dapatkan dia punya volumetric efficiency, ya. Next apa dia? Oh, dia suruh compare kan. So compare give you ni lah. You see kita dapati bahawa kita punya power turun sikit lah, ya. Kenapa power turun sikit? Sebab because of this m dot yang ada perkurangan lah. And then kita punya volumetric efficiency akan depreciate furthermore. Okay. Next, kita cuba lihat yang multi-stage pula. Very simple one, Okay, this question. Any question tak untuk regarding question 12.3 dengan 12.4? Any question? Tak ada, Okay. Now we go to 12.10 regarding our multi-stage. Okay, a 4-stage compressor work between limit of 1 bar and 112 bar. The index of compression in each stage is 1.28. The temperature at the start of the compression in each stage is 32 degrees C. And the intermediate pressure are also so chosen that the work is divided equally among the stages. Okay, kita ada apa Kita ada 4 stages. Kita ada 4 stages. 1, 2, 3, 4. Okay. Cuba tengok Dia kata kita nak pressurize dia pada 1 bar up to 112. So kalau masuk di sini adalah 1 bar. Yang kita nak keluar di sini adalah 112. Ini yang kita nakkan, 4 stages. Dan dia kata N value given right here is 1.28, the compression, the polytropic index. Okay. Dia kata the temperature at the start of compression. Okay, the start of compression. Macam mana Maksudnya apa? Kata each Let's say this is our piston. Ni kita punya piston yang berada pada BDC everything. So ni is our piston. This is our piston. Right? Maknanya sekarang ni everything should be at BDC. Ni lah sistem kita BDC. Sini adalah BDC. Sini adalah BDC. Sini pun BDC. The start of compression. Tengok start of compression. Dia kata apa? Dekat sini semua ada 32 degree C. 32. Ni pun 32. Okay. Kalau kita kompreskan dia, ini adalah T1 lah ya. Kalau untuk case first stage ni, this is T1. This is T1. So dia masuk kepada second stage, tapi suhunya 32. Meaning what? Kalau kita lihat kepada kita punya compression ni, after this compression, for sure 31 ni akan berubah kan? Lagi tinggi itulah. Betul?
Betul sir.
So maknanya apa? Maknanya kita akan cool down. Kita akan cool down dia, baru masuk 32. Meaning that, kita ada apa? Kita ada
intercooler.
Ya, kita ada intercooler. Mana at each stage, in between each stage, kita ada intercooler. Semua ada intercooler. Okay? So kita ada intercooler kat sini. Ada intercooler dekat sini. That's why kita dapat 32. So what case is this? Which case?
Complete intercooler.
Yes.
Complete
Intercooling. Complete intercooling. Okay. And then dia kata apa Dia kata 32. And the intermediate pressure are so chosen that the work is divided equally among the stages. Maknanya sekarang ni kalau kita ada stage 1 dekat sini, stage 1, kita ada stage 2, kita ada stage 3, and kita ada stage 4. Dia kata apa? Dia kata kerja yang diperlukan untuk memampatkan from 1 bar to 112 bar ni, each compressor akan kita gunakan dan dia memerlukan equal power input. So this is IP number 1, IP number 2, IP number 3, IP number 4. Dan dia kata semua sama. Jadi ini bermakna ini sama dengan 4 IP salah satulah. Saya ambil yang first stage. Equal kan? Semua ni equal dapatlah 4 IP. So apa case ni?
Same pressure ratio sir.
Yes, same pressure ratio. Same pressure ratio. Kalau complete intercooling, same pressure ratio, apa dia dapat?
Kita dapat minimum power.
Yes, bagus. Kita dapat kita punya sigma IP dia ada yang paling minimum. Okay? Very good. Right. Sekarang ni baru kita jawab soalan. Tadi kita buat apa? Kita translate all the information dalam bentuk diagram. Kita tengok satu persatu. Now, baru kita jawab soalan dia. Number 1. The temperature at delivery from each stage. Maknanya dia nak tahukan sini lah Sini, sini, sini dan sini. Kalau saya namakan ini sebagai P1, sekarang ni ada P1 dan P2 tak? Agak-agak lah. Kata tapi yang luar ni mesti katakan P, tak boleh tuliskan P1 Ini saya tuliskan ini sebagai P. Sekarang ni how about the P1? This is P2 How about the P1? Adakah sama dengan P? Okay. Ada tak dalam this question menerangkan bahawa the induction dengan free air condition berbeza? Tak ada
Rasa macam tak ada, sir.
So kita assume P equal to P1, T equal to T1. Okay? Right. So sekarang ni soalan 1 dia nakkan T apa? Kalau sini adalah 2, ini should be 2 prime. Kalau sini adalah 3, sini adalah 3 prime. Kalau sini adalah 4, sini adalah 4 prime. So ini jadi 5 lah. Okay? So ini jadi 1. Yang sama dengan P. Okay, 1, 2, 2, 3, 3, 4, 4, 5. Jadi apa yang kita nak sekarang ni adalah kita akan dapati bahawa kita perlu tahu apakah T2. T1, P2 over P1 N minus 1 over N. Okay? Dan kalau kita lihat kepada pressure ratio, the overall pressure ratio P5 over P1, maximum pressure divided by minimum pressure, P5 over P1, ni maximum, ini minimum. Yang ini sama pressure ratio-nya adalah, ini sama dengan P2 per P1 kalikan dengan P3 per P2 kalikan dengan P4 per P3 kalikan dengan P5 over P4. Ini adalah sama dengan P2 per P1 gandaan 1, 2, 3. 3 Ni kali ni jadi square. Sebab sama kan ni pressure ratio? Same pressure ratio. So this is the same as this. Dapatlah P2 keadaan 4. Okay. So therefore untuk mendapatkan apakah P2 per P1 ini sama dengan P5 over P1 1 over 4 which is equal to 112 divided by 1 over 4. Berapa tu?
Dapat 3.25, sir.
3.25.
Bah.
Therefore, mana lebah tak lebah tu ratio
Okay.
Mana lebah, ratio tak lebah. Okay, so what is our T2? T2 is equal to T1, 32 campur dengan 273 32 campur dengan 273 kalikan dengan 3.25 gandaan. Berapa dia punya indeks? 1.28. 1.28. So this is 1.28, 0.28 divided by 1.28. So what is the temperature? Okay guys, berapa?
385.3.
Apa? 3? Sorry.
394.7.
364.7?
39.
394.7? Okay. Kelvin. So that is our answer for the first part. Tolak dengan Joule 3 dapat ni tak?
Dapat sir.
Okay. And then number 2, the volume of free air delivered per kilowatt hour at 1.013 bar and 15 degrees C. Jadi yang nombor 2 ni kita punya P0 and T0. Ada P and T So nombor 2 ni kita ada P. P is given as 1013 dengan 15. 1.013 bar. T is equal to 288. Okay, dia nakkan apa ya? Dia nakkan free air delivery per kilowatt hour. Dia nakkan dia punya V dot ni dalam unit meter cube per kilowatt hour. So how do we do that? Kita nakkan free air delivery. So sekarang ni for every kilowatt hour. So kalau kita dapatkan V is equal to M R T over P. Kalau sini adalah dot, sini dot. Okay. So cuba lihat betul can we get M dot? Can we get M dot? Tak ada no way sebab tak ada volume kan. Tapi dia nakkan for every kilowatt hour. So how we convert that? Cuba kita kirakan dia punya V, kalau kita gunakan V sahaja, okay, kalau kita lihat for every one katakan M dot for every 1 kilogram per second. Cuba kita buat yang ni dulu. Kita assume that for every 1 kilogram per second, berapa dia punya V dot. Okay. So berapa ni? Ini adalah 1 multiply by R 0.287 kalikan dengan T kita adalah 288 dan kita punya 288 divided by P P kita adalah 101.3. Oh, dah 12.50 Okay. Guys, you try to continue soalan ni. Okay, saya kena off-kan dulu lah. Dah 12.50. Saya akan beri you all. You try to continue But that is the weak case lah. Jadi sekarang ni apa you buat, dapatkan untuk every 1 kilogram per second and then try to get also the IP for 1 second. For every 1 meter cube per ni per meter cube, M dot dia 1 kilogram per second and then try to dividekan V dot dengan IP tu. And then kalikan dengan 3600, you have to play around dengan unit. Basically kena play around dengan unit Nanti saya akan tunjukkan kepada you all lah. Tapi right now I have to get the attendance first. So our attendance for today. Today is Monday. Okay, so that is the link. Chat that is the link. Okay, nanti saya akan cuba tunjukkan, nanti saya akan buatkan, and then saya akan hantarkan that question dalam WhatsApp group dia punya.